Hi everybody, and welcome back to the video for task 4.4. In today's video, we are going to be working on solving literal equations. Now the word literal just means equations that have lots of letters in them. So we're going to be looking at equations today that don't just have x. They might have x's and y's, or x's and y's and z's, or p's and q's and r's. It doesn't matter. We're going to be solving them in a very similar way to how we've always solved equations. So the way we're going to do this is I would like to show you the connection between the way we've always solved and the new problems that we're going to solve. That means that we're going to do a problem with numbers before we do a problem with extra letters in it, so that you can see how it's basically the same thing. So let's try number one. Number one should look like a very familiar question. We've done lots of problems like this already. In order to solve an equation like this, you would start by adding 3 on both sides. Now when you add 3, you end up with 2x equals 9 plus 3 makes 12. And then you would divide by 2 on both sides, which means you would get x equals 12 divided by 2, which is 6. Now again, we've solved lots of equations like this before. Now take a look at problem number 2. You'll notice that problem number 2 is exactly the same equation as problem number 1. The only difference is that instead of just 2x minus 3, we have 2x minus 3y. So let's take a look how we would solve an equation like this one. If I wanted to get x by itself, the first thing that I would do here is plus 3y. Just like over here I did plus 3, here I'm just doing plus 3y because now there's a y next to the 3. On the left-hand side, the plus 3y and the minus 3y would cancel, and so I just would bring down my 2x. Now on the right-hand side, in this problem, we were able to do 9 plus 3 and get 12. But in this problem, since we don't know the value of y, and these are not like terms, we can't combine them. So what we're going to do is just write both of them down without simplifying. 9 plus 3y. So you'll notice I literally just wrote down the 9 plus the 3y. Now the next step in this problem was to divide by 2 on both sides. And we're going to do the same thing in problem number 2. We're going to divide by 2 on both sides. So I'm going to get x equals, now in problem number 1, we were able to actually compute 12 divided by 2. We could calculate that and get 6. In problem number 2, since I don't know what y is, and since 9 and 3 do not nicely divide by 2, which I could try to divide them each by 2. Since they don't divide nicely, I'm just going to leave the dividing by 2 the way that it is. So my final answer here would be 9 plus 3y all divided by 2, and that's literally the answer. Your answer for a problem where there's more than one variable in it is going to be an answer that has more than one variable in it. It's not going to be an answer that's just a number because we don't know all of the numbers here. Let's try number 3. So in number 3, this looks like a problem we've done lots of times. In order to solve a problem like this, I would start by multiplying by 5 on both sides. When I multiply by 5, this 5 cancels this 5, and 7 times 5 is 35. I'm also going to just drop down my 3x plus 2. Next, I would subtract 2 on both sides. When I subtract 2, I get 3x equals 33. Lastly, I'm going to divide by 3, which means x is going to be equal to 11. Okay, take a look at problem 4. In problem 4, you'll notice it's a very similar problem to problem 3. It's just that instead of having 3x plus 2, we have 3x plus 2y. So let's see how we would solve problem 4. Now the first thing we did here was multiply by 5, so let's do that first here as well. I'm going to multiply by 5. When I do that, I'm going to drop down my 3x plus 2y, and 7 times 5 is 35. So far, so good. The next thing I did here was I subtracted 2. So in problem number 4, I'm going to subtract 2y. Now you'll notice I'm not just subtracting 2 this time because the 2 is attached to a y. I'm going to subtract that whole term. Now on the left-hand side, these are going to cancel, so I'm just going to bring down my 3x. And on the right-hand side, because the 35 and the minus 2y are not like terms, we can't combine them. So we're just going to bring them both down. 35 minus 2y. And don't simplify, just leave it like that. Lastly, here we divided by 3, and here we're going to divide everything by 3. Now, in problem number 3, we were actually able to compute 33 divided by 3. We could calculate that and get 11. But in this problem, we don't know the value of y, and 35 and 2 do not divide nicely by 3. So instead, I'm just going to copy this whole thing down, and that's going to be my answer. Again, you'll notice that when we have a problem that starts with more than one variable, we're going to have an answer that ends with more than one variable, and it's not going to be simplified because we can't simplify if we don't know the value of that missing number. Let's try problem 5. So in problem number 5, we're going to draw our vertical line, and we're going to go ahead and add 5 on both sides. Now again, we've solved problems like this before, so we're just following our usual steps here for getting x by itself. 11 plus 5 is 16. When you multiply by 3 on both sides, you're going to get 4x equals 16 times 3, which is 48. Last but not least, you're going to go ahead and divide by 4. And when you divide by 4, you get x equals 48 divided by 4, which is 12. For problem number 6, you'll notice it's a very similar problem. The only difference is that instead of minus 5, we have minus 5y. So in order to solve this problem, I'm actually going to start by adding 5y on both sides. I'm not just adding 5, I'm adding 5y because those are attached to each other. It's all one term. Now, I don't know what y is, and 11 doesn't have a y, so these two terms are not like terms, which means I'm not going to simplify, I'm just going to copy them both down and put them next to each other. Next thing that I did here was I multiplied by 3. So the next thing I'm going to do here is multiply by 3. I'm going to go ahead and drop down my 4x, and then I'm going to show that I multiplied everything that was here by 3. To show that, I'm going to put 3 parentheses 11 plus 5y. I'm showing I'm multiplying everything that was there by 3. Next, I'm going to divide by 4, just like here I divided by 4. So if I divide by 4 in this problem, since 3 does not divide nicely by 4, this is not something that I'm going to simplify. So I'm just going to bring down the 3 parentheses 11 plus 5y and write divided by 4 underneath, and that is my answer. Okay, let's try a few more examples. So in problem number 7, the first thing I would do to solve this problem would be to multiply by 5. That means I'm going to have 2 parentheses x plus 3 equals 6 times 5 is 30. Next, I would divide by 2. Now when I divide by 2, I get x plus 3 equals 30 divided by 2, which is 15. And last but not least, I would subtract 3 on both sides. And so I would get x equals 15 minus 3, which is 12. For problem number 8, I can see that it's a very similar problem, only instead of x plus 3, it's going to be x plus y. I'm going to start solving this problem the same way. So I'm going to multiply by 5 on both sides. That means I'm going to have 2 parentheses x plus y equals 6 times 5 gives me 30. Then I'm going to divide by 2. You'll notice again, this is very similar to how we did number 7. We're following the same steps. So we get x plus y equals 30 divided by 2 is 15. Last but not least, I would subtract y. Just like I subtracted 3 here, I'm subtracting y here. So I'm going to get x equals, now you'll notice in this problem I could actually do 15 minus 3. Here I don't know what y is, and those are not like terms. So I'm just going to write 15 minus y, and that's my final answer. In problem number 9, I'm going to draw a vertical line through my equal sign. The first thing that I would do in this problem would be to divide by 2. And the reason I'm going to divide by 2 is to get rid of the parentheses. And this works out because the 4 and the 12 are both divisible by 2 nicely. So 4 divided by 2 gives me 2x, and 12 divided by 2 gives me 6. And on the other side, I just drop down my 3x plus 4. Next, I would need to get my x's together. So I'm going to subtract 2x on both sides in order to have all my x's together. That is going to give me 1x, and these are going to cancel. And so I'm going to have plus 4 equals 6. And last but not least, I'm going to subtract 4 on both sides in order to get x alone, which is going to give me x equals 2. Now let's see if we can figure out number 10. Now you'll notice number 10 looks very similar. The only difference is that there's a 4y here instead of just a 4. So let's see. The first thing that I'm going to do is I'm going to divide by 2, and this works out for me because the 4 and the 12 are nicely divisible. Remember, if these numbers were not nicely divisible by 2, we could always distribute instead. So the 2's cancel, and 4 divided by 2 gives me 2x, and 12 divided by 2 gives me 6y. And I'm going to go ahead and drop down my 3x plus 4y equals. Next, I'm going to get my x's together. So I'm going to subtract 2x on both sides. And when I do that, that gives me 1x, and then the x's cancel. And I'm just going to drop down my plus 4y and my 6y. Last but not least, this time, instead of just subtracting 4, I'm going to subtract 4y on both sides. And 6 minus 4 is 2y as my answer. All right, let's do problem 11. So problem 11 has a lot of numbers in it. So let's see if we can figure this guy out. The first thing that I would do here is add 7. So I'm going to add 7 on both sides. And that's going to give me 3x plus 4 all divided by 2 equals 4 plus 7 is 11. Next, I'm going to go ahead and multiply by 2 on both sides. And that gives me 3x plus 4 equals 11 times 2 is 22. Next, I would subtract 4 on both sides. And so that is going to give me 3x equals 22 minus 4 is 18. And lastly, I'm going to divide by 3 on both sides, which gives me x equals 6. Now you'll notice that number 12 has a very similar structure, but there's a lot more letters in it. So let's see if we can figure that out. The first thing that I'm going to do here is I'm going to add d on both sides. That's going to give me ax plus b all divided by c equals, now I don't know what e is and I don't know what d is, so I can't combine them. They're not like terms. So I'm just going to write e plus d. Next, over here, we multiplied by 2. So over here, the next step would be to multiply by c. So I'm going to get ax plus b equals, now again, I don't know any of these numbers, so I'm just going to write c and then parentheses e plus d to show that I'm multiplying everything by c. The next step here was to subtract 4. So the next step here is going to be to subtract b. So I get AX equals C parentheses E plus D minus B. And last but not least, oh, and by the way, I'm putting the minus B here because I don't know any of these numbers. I can't simplify. I just copy it down. And last but not least, I'm going to divide everything by A. Now again, I don't know any of these numbers. So X would be equal to all of this stuff, C parentheses E plus D minus B, all divided by A. And that would be my final answer. Whoop, you can't even see what I wrote. There we go. All right, we have a few more problems. I promise we're almost done here. So for problem number 13, we're going to go ahead and get X by itself. In order to do that, we're just going to divide by 3 on both sides. So the 3's cancel, and we just get 5 equals X. Now you'll notice in this problem, we're not using X's and Y's anymore. Instead, it says here solve for H. When it says solve for H, this means get H alone. So get H by itself. Well, in this problem, here's the H. And right now it's being multiplied by B, just like this X was being multiplied by 3. So in order to get H by itself, I would divide by B here, just like I divided by 3 here. Now, because I don't know what A is and I don't know what B is, my final answer would just be A divided by B. And that's my answer. For problem number 15, it says get X by itself, so we're going to subtract 3 on both sides. And we're going to get X equals 7 minus 3 is 4. Now in problem number 16, it says solve for B. When it says solve for B, that means get B alone. So I want to get B by itself. Now, just like here, when we had X plus 3, we had to minus 3 to get X by itself. Here we have A plus B, so we're going to have to minus A to get B by itself. So I'm going to have B equals, and now I don't know what D is and I don't know what A is. So my final answer is just going to be D minus A because those are not like terms and I can't simplify them. All right, thank you all so much for watching. I hope that you have a great day and I will see you all for some practice soon.